Alright, so we're going to do here completing the square, but this time the non-graphing edition. So this one is actually going to be solving quadratic equations utilizing completing the square method. So let's look at something here real quick as a reminder. Okay, so let's review this. So last time, or there was a while back, we did this where we would solve by square roots, where we would say, okay, some number, something, or x plus 3 squared is equal to 36. So if I take the square root, I would get, say, square and square roots cancel each other out, leaving me x plus 3 is equal to the square root of 36, which is 6. But when we're doing quadratics, and algebraically, we say plus or minus 6, because positive 6 is the square root of 36, and so is negative 6, because negative 6 squared is 36. Then we would say x plus 3 is equal to positive 6, or x plus 3 is equal to negative 6, subtract 3 from both sides, and we would get one answer as 3, and the other answer as negative 9. So you're always adding and subtracting that plus minus. Okay, so with that idea, okay, now let's look at completing the square. In completing the square, what we did for the graph, or for graphing, we would say divide the negative 12 by 2 and say minus 6, and then we would square that and put plus 36. Now that would complete that square. So their x squared minus 12x plus 36 would, be the factored form of that, or the perfect square form of that is x minus 6 squared. Now, for balance, we would always say, in the graphing part of it, we would say if I put plus 36 in the parentheses, I'm putting a minus 36 outside the parentheses. Well, if you're putting plus 36 on the left side, on this one, you're putting plus 36 on the right side. So notice here, balance. What you put on the left, you put out exactly the same thing on the right side. This is different than the graphing because on this one, we have it equal to. Okay, so 36 minus 11, or negative 11 plus 36, is 25. Again, take the square root. You get x minus 6 is equal to plus or minus 5, so x minus 6 is equal to 5, x minus 6 is equal to negative 5, which would give you 11 and 1. And that's it. Okay, so kind of pay attention to what you got to do here. This is should be kind of a review. The next one. Okay, so here's where we go the full steps here. You need to have the x's by themselves. So if there's any number there with it, then you need to move it to the other side. So I'm going to say x squared minus 10x equals, and plus positive 21 moved to the other side will be positive 24. I couldn't see that with something being covered over the 4. Negative 24. So okay, the positive 24 moves over to the other side, it's negative 24. Now I can complete the square. So I'm going to divide 10 by 2, get negative 5, square that as 25. Notice that I'm saying 25 over there also. 25 minus 24 is 1. Square root of 1 is plus or minus 1. And then I can say add 5 to those both sides and say x is equal to 6 or x is equal to 4. Okay? So the key there, again, is always get the x's by themselves. Okay, same thing. We're going to move that 50-something over to the other side. X squared, 53. Okay, so divide by 2. 14 divided by 2 is 7. 7 squared is 49. Notice I'm putting plus 49 on both sides. Negative 53 times 49. I'm sorry, negative 53 plus 49 is negative 4. Okay, and remember, when you take the square root of negative 4, the square root of 4 is 2, but the negative there makes it I, 2i. So we have plus and minus 2i. Now, if I try to subtract 7 from that, I actually can't. So I would leave it like that. Negative 7 plus or minus 2i. So kind of keep that in mind that with I, there are problems where I could give you with an answer in I or a simplified radical. So just kind of go with that. I think that comes up later. Alright, so now what do I do with numbers in the front? Alright, so here's where you probably won't like me because you're going to have to deal with fractions. Not fractions. Yes, fractions. Okay, so I'm going to divide by 2. So now I have x squared minus 7 halves x plus 5 halves. Now, folks, this could be very easy if you use a calculator. The inspired calculators make this a little bit easier, I guess, with fractions. Either way, the 5 halves has to move over to the other side. I still would not recommend using decimals with this, by the way. Okay, so I have negative 5 halves over there. So now I'm going to divide that by 2. Now remember this, dividing by 2 is the same thing as multiplying by 1 half. So you could type in negative 7 halves and multiply that by 1 half to get negative 7 fourths. 7 fourths squared, you can type that in the calculator, would tell you 49 over 16. So I would put 49 over 16 there. And then I could type in the calculator negative 5 halves plus 49 over 16. This is one of those where I would recommend you actually type it in on the calculator, write what you need to write on your paper, but then type that operation on the calculator. So like here I would have said negative 5 halves plus 49 over 16. I would have typed it in just like that, press enter, and the calculator would have told you 9/16. Do the 9/16, now take the square root, so then you would type into the calculator square root of 9/16, and it would tell you 3/4. So you would have to put plus minus 3/4. Then you can move the 7/4 over to the other side, and you can say 3/4 plus 7/4, press enter, and then negative 3/4 plus 7/4, press enter, and it would give you 5 halves and 1. So it's kind of simple depending on how you look at it. But it is one of those, it would take practice. So I highly recommend for those of you like think you can just kind of sit around and clown around in class and not do anything, you need to make sure you're practicing these type of problems. Alright, another example. Again, first thing I got to do is divide by 3. So now you can see there's my fractions. Move the 8/3 to the other side. So it's going to become positive 8/3. Divide by 2, which means multiply by 1 half, and I would get 5/3. Okay, so the calculator, that's what it would give me. Square that, I get 25/9. Add those together, and you get 49 over 9. Take the square root, you get 7/3, plus or minus. Okay, and then you can subtract and type it in your calculator. Now, the easy part about this is that you're going like this in the calculator. You're typing in 7/3 minus 5/3, press enter, and then if you press up 2 times, you can copy and paste and then just stick a little negative in front, press enter again, and that's where you'll get the second answer. So kind of keep that in mind. And if you're not sure what to do, ask in class. Let me go over it with y'all in the calculator. Let me show you the calculator. But you've got to ask questions, kiddos. You can't just sit there and go, are there any questions? No. And then you complain, I don't understand. You got to ask questions. Alright. Keep it going, keep it going, keep it going. Okay, so here's one last example. I'm going to move the 4 over to the other side. Divide by 2, square it. I get 20. Take the square root. There is no even square root of 20. So this goes back to where we do the perfect squared method or the factor tree, whatever. The largest perfect square that goes into 20 is 4. The square root of 4 is 2. So that would be on the outside. 5 would be left in the inside. And then since this is in a radical form, when I move the 4 over to the other side and make it negative 4, like subtracting 4, there's nothing I can do with that. So I have to leave it as that, negative 4 plus or minus 2 square root of 5. I would prefer that over the decimal answer. You need to get used to the idea of simplifying the radical. Okay? That's it for today. That is completing the square. If you have questions, make sure to ask on next time I see y'all. Y'all take care. Thank you very much.